would be good, right? I can't guarantee that, though. That's his job. Okay. Now I just need that, and we'll be good to go. Perfect. Okay. If you were confused as to which talk you're in, it's this one. Hopefully you know this one you're expecting. And I don't have a button. There we go. So I was told that every great talk begins with a great quote. I don't know if this qualifies in either case, but I do like this quote. I'm not going to tell you who the vendor is. I'll let you guys guess later. Maybe I'll give you something for it. But I am an operations guy. And specifically, I'm the operations guy for LinkedIn. So when I started with Hadoop in May of 2007, so I've been doing this for almost 6 years. I started at Yahoo when they had around 5,000 nodes. I left there at the 22,000 node mark and got sucked into LinkedIn when we had 20 nodes. So this was my first day at LinkedIn. And this is sort of what I walked into. 20 nodes, what is now probably an ancient version of Hadoop. No configuration management, no monitoring. We did have metrics. That's something. Security, of course, didn't exist in Hadoop. And it was just a mess. The big thing, of course, is that there was no operational support till they hired me. So I was the first operations guy for LinkedIn. Now, even though they had metrics, they really didn't look at them. And these are some of the things that I saw. And I actually see this talking to other folks. They say, oh, Hadoop is very I/O bound, so we're going to make these big machines that have lots of disks. And then they start looking at the CPU numbers, and they start throwing on lots of tasks. This is what happens when you do that. All your CPU is spent waiting for I/O. And this is exactly what LinkedIn had. So what I want to walk you through is, that was my first day at LinkedIn. I'm going to walk you from that first day to where we are today, in mostly chronological order. So the first year was clearly dictated towards fixing performance, because performance obviously was very bad. And just sort of getting us operationally someplace good, because we were definitely not someplace good. First thing, I dropped the task count, which sounds insane, because a lot of people are running with things like 20 mappers and 20 reducers, and they think their performance is great. I actually cut mine down. I actually had a fight with the development team. I was like, this is what I'm doing. And our performance went up. We reworked the ETL. This is something that a lot of people don't really understand. Input matters. In our case, it mattered tremendously. Dropping a job from 80,000 map tasks to 2,000 map tasks and cutting the time it took to run just by changing the input is significant. And this is just indicative of sort of the problems that we saw. More importantly, though, is we started doing a culture shift. What we saw a lot of is, well, I keep adding tasks, it'll get faster, it'll get faster, and it'll get faster. And we needed to stop that. We really needed to spend, okay, instead of having 5 map tasks that took 2 seconds, let's have 1 map task that take 30 seconds, or whatever. Ideally, we try to push for 5 minutes minimum task time. Obviously, we're not doing real time, right? And in order to fix this, we started doing production reviews. So this may be some sort of odd to some of you folks. In a web space, most development teams push directly to production. There is no operational review. They sort of like pick it up after it's already in production. For Hadoop at LinkedIn, we actually did the reverse. When you deploy to production, you actually have to go through an operational review. And the whole purpose of that was to make this culture shift happen. And in the end, it paid off. One of the other things I did is I switched this over to Capacity Scheduler. Now, this is where one of many things that I'm going to basically tell you something different than probably your vendors are telling you. One of the things that I did is I said, you know what? we're not going to have queues per workflow. Many people say, I need a dedicated queue for this production job, so I make sure it has resources. This way it will always run, no problem, right? I said, no, that's dumb, because what's going to happen is when that job isn't running, there's a very good chance those resources are sitting idle. That's a waste of money. So instead, I flipped it around, and we're actually using SLAs for the queues. So if you have something that runs very, very quickly, you put it in the fast queue. If you have something that takes a really long time, you put it in the slow queue. This has an interesting impact on the culture. There was a benefit to the users to making their code run faster. If I can get more resources and actually runs faster, I'm going to go that way. I don't want to be stuck behind the big truck or the train coming, sitting in the slow queue. So there was a big carrot in helping people shift how they work their jobs. Additionally, we wanted to make sure that the jar size was reasonable. The submitted jar actually has a pretty big impact on performance. So we put a limit on how big that jar could be. Use distributed cache. It helps performance. So, of course, that's the software side of things. What about on the hardware? So, LinkedIn, I think, is sort of notorious for having very unusual workloads, especially on the CPU usage. And so one of the things that I did early on was, okay, they bought this hardware before I got there. Was it right? Yeah, this is the recommended standard that everyone tells us that everybody should have in their Hadoop systems. Well, is it the right thing? I actually verified it, and I found out that the answer was no. It was not the right thing. So I reduced the number of drives, and by doing that, I could go from a 2U to a 1U. Well, think about your rack. I just cut my rack usage in half. Less metal per square foot means I can actually put more in the data center. And if I'm getting just the same level of efficiency, that's fantastic. I can also cut down my costs. 2U machines are more expensive than 1U machines, right? Simple math. I actually am not going to talk too much about this sort of benchmarking. I hear that some of you have seen another presentation I posted on SlideShare. And I'll make a reference to that if you haven't seen that, but that covers it more in depth than some of the things that I do for performance. They didn't have monitoring. This is Nagios. I know everybody hates Nagios, right? You can go ahead, you can say it, I know it. The thing is that if you're looking at the screen a lot, you're doing it wrong. So my team, whenever we have a problem, this sends us a text message. And then we go fix it. We never look at the screen. We never see it. This is the first time I've actually seen this screen in 2 years. The other thing is that if you, probably hard to see in the back, is that we don't actually check every node. We check the master nodes, a couple key services, that's it. We let the master nodes do the work for us. The name node knows how many data nodes are up. Why should we ask every individual node? That doesn't make sense. So we ask the name node, we ask the job tracker, how many nodes do you have? We alert on a percentage. If 30% is down, we're in trouble. But we actually start alerting at like 10%, 5%. This way we know ahead of time, okay, it's not crisis, but we need to do something about it. So year 2. So at this point, things are stable, fairly performant, and we're starting to go on to the next big adventure. At this point, we've learned what our capacity requirements are. We were doubling every 6 months. The data center guys hated me. So we basically, one of the big things we started doing in year 2 was LinkedIn traditionally was a Solaris company. We were heavy-duty, hardcore Sun folks. I'm actually ex-Sun, which is one of the reasons why they let me in the door. Oracle buys Sun, corporate decision has to be made, we decided to switch to Linux. So, which means reinventing a lot of back-end infrastructure. For Linux installations, I picked Cobbler. Cobbler actually can do a lot of things. It's an ex-Red Hat project. We don't use Cobbler to the full power that it can.
We mainly use it for disk partitioning, and we let other stuff take care of other things, which I'll get to in a second. When it comes to disk partitioning, though, we do things a little differently. This is also where the vendors will probably say, you blasphemer. I'm not a big fan of having one big fat partition and one big fat file system for MapReduce and HDFS. You'll notice whenever people talk about HDFS capacity, they always talk about non-HDFS. They used to take that into consideration. And I asked the question, why? Why should I? Instead, I opted to actually put MapReduce spill into its own partition. This has lots and lots of advantages. Number one, I know what my HDFS capacity is every single moment of the day. Ask yourself, do you? The other thing is think about this from a different perspective. Running a MapReduce job, running. I'm spilling, because I have very bad code. I'm spilling. If I spill 200 gig, do I really want that job to continue? I mean, performance-wise, it's going to be terrible. Something's clearly going wrong. I'd rather kill it with a file full and keep moving and not bring down the whole system, which is what eventually would happen with enough of these on the box in a shared file system. We do some mount options, make things faster. This is another thing where the vendors may be telling you something you shouldn't be doing. I actually had an interesting discussion earlier today about this. Our named node and job tracker, we use the exact same hardware, exact same configuration as our compute nodes, as our data node and task tracker. The only thing that's different is more memory. So whenever you have someone who says, oh, well, you can use commodity for the compute part, but not for the named node and job tracker. No, sorry, they're wrong. This will be my, I think I'm up to my 30th Hadoop grid I've set up now, and I've never done special hardware for the named node and job tracker. This includes using software RAID. I don't even use RAID cards. In fact, I reject vendors that insist they have to have a RAID card in my box. No, you increased my cost. Why do I want a RAID card? And in fact, in most cases, it's actually going to slow me down because I've done the benchmarking. Why do I want a RAID card? So the other thing is that many web startups have a tendency to push Etsy password and Etsy shadow as this weird sort of process to the individual nodes. Those of you from the enterprise space are going, oh my gosh, those people are insane. And you're right, they are. So one of the things I had to do was basically deploy a naming system. We've had a track record at Yahoo where they use the Etsy password local machine thing. Now, keep in mind that in case of Yahoo, it was 1,200 accounts going to every machine. Someone would run a job, and their account wouldn't exist on like half the nodes yet. Then the job would fail because the user wasn't recognized. That's bad. So clearly using something like LDAP, Kerberos, those sorts of things works out well here. One of the big concerns that people usually have with LDAP is, oh, well, it's going to be slow, and I have to scale my LDAP infrastructure, and those sorts of things. That's what the naming services cache daemon is on the Linux boxes for, or Solaris, or whatever. Almost every OS has this. That takes the load off your LDAP servers. So I talked about provisioning, and a lot of people use Puppet or Chef or insert vendor Hadoop special thing here. I don't. I use BCONFIG 2. And I know all of you are going, what is BCONFIG 2? So BCONFIG 2 actually predates Puppet. It predates Chef. It's not as old as CF Engine. It actually is from the HPC space, from the high performance computing guys. In fact, BCONFIG 2 is mainly housed at Argonne National Labs in Chicago. It takes configuration management in a slightly different direction. So think about how you deploy machines today. You probably have some sort of, this host needs to look like this, right? Very common. BCONFIG 2 flips that. I can say, that the host actually determines what services are supposed to run on itself. And it actually asks the server for the components to make that happen. Think about how powerful that is. If I want to mix an LDAP server and a Zookeeper server on the same machine, I can do that. Sure. I'm about to get to that. It's a great question. So the BCONFIG 2 client, what it actually does to determine what it needs is you basically write a probe script, and it's part of the client config. In our case, we actually tie that back to LDAP. We use net groups to say, this service needs to be deployed to these hosts, this service needs to be deployed to these hosts, this service needs to be deployed to these set of hosts. By using this, we can mix and match services all we want, because BCONFIG 2 will take care of any conflict resolution, it'll take care of any duplicate RPMs, it'll do all those sorts of things. Think about this from a Hadoop upgrade perspective. If I reconfigure my RPMs such that they deploy in different locations, I can theoretically have multiple versions of Hadoop with multiple configs on the same box installed. Now I'm doing an upgrade. And let's say I grab the Apache RPM, or even the Hortonworks RPM, or the Cloudera RPM, or anybody else's RPM, and I want to do an upgrade. What's the first thing I have to do? Bring everything down. So I have my entire system down. I'm now doing yum install, and in my case, I'm doing this across, let's say, 800 nodes. It's going to take a while, right? In worst case, it's not actually going to install on all these machines the first time. So now I got to go find them, right? So then I got to spend time doing that. And then, okay, hopefully I didn't miss anything. Now I bring the system up. And then I found out, oh, I did miss this thing over here. And I had to go through all this work. With BCONFIG 2, and we basically built our own RPMs so that we can do different installations, different locations. A day before, 48 hours before, we can tell BCONFIG 2, okay, this host has 2 services on it. It has old Hadoop, and it has new Hadoop. So we can have both binaries installed. And you saw that screen where it had green and red. The red ones are the ones that are missing the component. Something's wrong with that install. So I can actually do a visual inspection before the upgrade, fix them, and I'm still up. I don't actually take the downtime until I flip binaries. So my downtime for an upgrade is 5, 10 minutes, if that. Hopefully someday in the magical future, we won't have to take downtimes for Hadoop upgrades, and we can actually do them on the fly. But we're not there yet. And so this was our solution to that problem. The other thing to consider is a lot of the tools that the vendors are building are geared towards the server, right? The Hadoop server, whatever that is. I'm using the same system for LDAP servers, for Kerberos servers, for client machines that actually don't run Hadoop but need it there, Voldemort servers, whatever I need. So I'm actually using the same configuration system for everything, for my entire data center. Year 3. So at this point, we have our upgrade story, we have our configuration story, we have our monitoring story. Everything looks great, right? So we're starting to work on the harder stuff. And we're starting to prepare for security, and we're starting to reduce user friction. At this point, LinkedIn has about 2,000, 3,000 machines running Hadoop. We have more than a quarter of our user base with Hadoop accounts. Now, LinkedIn's today is only 3,500 employees, but considering at this point my team had 3 people to support these 35, or the 300, 400 accounts, pretty crazy, right? So on the security side of it, and on the reduced user friction side of it, we started to deploy Kerberos. for our user authentication. Now, I've heard through the grapevine this is a problem that many, and did I say many, people have. Now, so I'm this renegade person inside the company doing crazy things, and I go to corporate IT and say, I want to hook into your authentication systems. Now, you're corp IT. You take one look at me, and you go, I am not trusting you. And I don't blame them. I wouldn't trust me either. But we can set up a one-way trust. And so what this one-way trust does is it says a user can use their corporate IT password and will accept it on the Hadoop side. We trust them, but they don't trust us. So even though we can log into our machines and do whatever we need to do, the corporate IT side's like, whatever. There's a huge benefit of doing this. When we first started having the discussion around Kerberos at LinkedIn, there was talk about, well, let's just put the Hadoop machines into the corporate environment. And then I said, well, I understand why that would be useful, because then you can control the entire Kerberos infrastructure. I have 2,000 machines. I'm going to need 4,000 plus credentials created. Corp IT, do you really want to do that? And of course, like smart Corp IT people, they backed off and said no. I said, but what we can do is we can set up this one trust, and that's all you have to do, and you'll never hear from me again. I lied, but don't tell them that. This is something that you guys really want to think about doing. It makes your life easier and allows you to do some cool stuff, which I'll get to in a second after this brief intermission. So we started to work on getting secure Hadoop. Now, this is a talk in and of itself. And someday I'll do it. It may take bribery of alcohol, but I can talk about it. Some highlights, though. We spent 6 months moving, just getting a working Hadoop. This was after the claims of stable from the Apache community. We basically ended up having to fork the Kerberos web filter because the code was just terrible. We found numerous bugs that actually broke functionality. We ended up replacing the communication between the secondary name node and the primary name node. We actually rewrote that. One of our guys rewrote that. It's a very painful story, but in the long run, it was worth it because we got so much more. I don't know if you noticed on the first slide, or one of the earlier slides, I talked about random mafia hits to jobs. This stopped that. But because we deployed Kerberos as part of security, and because we did this whole SSO thing, the single sign-on thing with the corporate IT systems, account management for us got really easy. It got really easy. And so when someone requests a Hadoop account, we can look at their credentials in their web browser. We know who they are. They've been validated by corporate IT. And they literally just click on a button and they get an account active. And this system actually sets up their home directory in Unix. It sets up their home directory in HDFS. For those insane people that want to use Hive, it sets up Hive tables. It does all those sorts of things for us. The touch points from my team went to 0. So it was really about reducing user friction. Of course, if I know the user, I can do other things too. And that's like group management. And so same thing. So we have secure Hadoop. Groups mean something now. So all those groups that are running around in the file system, again, my team's touch points went to 0 because now users can manage themselves. And of course, I have to point out that you should notice that the user that I'm adding is this could be you. We are hiring. So that brings us to today. So as of today, we are about 5,000 nodes and about 10 grids. Long way away from 20 nodes and one person, right? We're running Hadoop with some custom patches, the SLA patch for queues, some of the security changes here and there and elsewhere. We have full configuration management using open source stuff. We have full monitoring. We got security, et cetera, et cetera, et cetera. It's all good stuff. Now here's the part where if you're a CIO, you would be really happy. We support these 5,000 machines with 5 people. Pretty good, right? Not bad. Because we're still growing like crazy, my expectation is it will be between 10 and 12,000 nodes by the end of the year. Now, using that ratio, you can probably guess how many people I plan on adding to the team. It's still great, right? And this is what our performance looks like now. That blue is CPU time by the user. Now we have new problems. The CPU vendors don't like us because we break things. But yeah, that red, that's sort of near the tail end, that's actually the tail end of the reduce writes. And the blue starting up is another job coming in. And that pause, I just happened to catch it right when I was doing something non-Hadoop. But this, by the way, this graph is from if you're a LinkedIn member, and you are, right? Yes? No? Okay. Please say yes, even if you're lying. You know that corner where it says people you may know? This is a graph of it. This is an hour snapshot of it running. So yeah, we work hard on performance. So of course, you may be saying to yourselves, but Alan, everything looks great. Is there anything you would ever do differently? And so I kind of want to answer that sort of question. And the question that's been keeping me up at night is pure Hadoop the right tool for our workloads? So we do a lot of weird things. We don't have the largest social graph, but one that's fairly large. I won't name who that other people are. But when you're doing graph processing, MapReduce is not great. That's one of the reasons why the CPU load is so high. Right? And so I've been thinking more and more about a hybrid system. So of course, Yarn and HDFS is 0.23 or Hadoop 2 or whichever version of the week is currently being touted as the best. But that only solves part of our problems. So I've been thinking a lot about, well, what could we do differently? And so I'm actually kind of want to go a little old school. And I want to go to PBS, Portable Batch System. Those of you that are from the HPC space probably recognize the name Torque, Maui, Sun Grid Engine, those sorts of systems. And that's what PBS is. That's actually an IEEE standard, 9. And I kind of want to put that alongside Yarn in order for us to do things that Yarn isn't capable of doing today. There's some overhead with Yarn. Case in point, I can take an MPI job and run on PBS after deploying PBS like tomorrow. If I want to do it on Yarn, I have to build all this Yarn framework stuff first, get that working, and then I can do work. So why wouldn't I just go ahead and deploy something alongside it and do those sorts of things now? Additionally, HDFS, it's a great serial file system. Serial I/O is fantastic at. We do a lot of things that aren't serial. They're actually more random I/O. And so we're looking at systems like Ceph and Gluster and other systems. We're currently looking at Ceph to sit alongside HDFS. You know how I talked about how BCONFIG 2 deploys services? You can see how this works really, really well. Because I can define a host as it being Yarn plus Ceph, and it will deploy the necessary components. Or I can say this host should be HDFS and Yarn, and it will deploy the necessary components. So because we've done this groundwork of doing the configuration management system in such a way that we can overlay services, I can do this mix and match very, very easily. So Ceph gives us things like block stores. So what if I wanted to put like eucalyptus as a next column in this graph? It'd be simple, right? I just deploy another service in BCONFIG 2 that's eucalyptus. I say this node is now a Ceph and eucalyptus node, and I'm done. So these are the sorts of things that I've been thinking about is where I want to take LinkedIn infrastructure-wise into the future. And that's sort of where I'm at. Oh, just about on time, too. So this is a link to the performance slide deck that I mentioned earlier. I know some of you have seen it. I know I've gotten a lot of questions about it. If you haven't seen it, that's where it's at. It talks a lot about what sort of things that we do to make our numbers go from a lot of red to a lot of blue. Take a look at that. And of course, a link to the data analytics team at LinkedIn. And other than that, I'll take whatever questions you may have after I take a drink of water. Sure. Yeah, I agree. BCONFIG 2 uses XML, and it's kind of tricky. The newer versions, like 1.2 and 1.3, are way better to manipulate. It's still a bit of a learning curve, but almost all configuration management systems are, right? This one's a little harder because it does flip the model. We found it's actually worth it to sit down and go through the pain. And we're actually, I know it sounds terrible, but having lived through Hadoop 0.11, trust me, it's not that bad. And Owen's ready to kill me. Yes? So the question was what types of workloads generate, especially the blue graph, right? Yeah. Most of our stuff is very CPU intensive because of social graph work. Because we're trying to simulate graph theory in MapReduce, we do lots of things that you shouldn't be doing in MapReduce. And we'll be the first people to admit it, that we're doing things we should not be doing with Hadoop. In fact, the other folks in the Hadoop community kind of look at us like we don't want to know. As a result, that particular job, I think I remember which job it was, is basically a triangle closing operation, if you're familiar with graph theory. So you have, a point, and you're trying to connect the graph, right? It's a triangle. Imagine doing that in MapReduce, and you can see where things go crazy very, very fast, right? Which is why it was important for us to optimize everything else to make sure that we didn't hit these weird edge cases. We still hit edge cases on a regular basis. The rest of the core committer community is always really scared when we hit an edge case because it usually means that other people will hit it later. So when we're in panic mode, they're in panic mode, which is kind of nice. Sure. Sure. So the question was around 2 1 gig versus just a plain 1 gig, and then what we're thinking about 10 gig. So LinkedIn at that point in time, they bought the 2 gig interface. They bought the 2 1 gig interfaces because they were treating Hadoop like they would all their other services. What this meant is it was highly failover capable. So they literally had 2 separate physical networks. So in case one network went down, the other network could pick up the load. For those of you who have done Hadoop and you're thinking about decommissioning, you can pretty much guess where this goes. You lose like a half of your packets going to the data node, and half to the name node, and half the packets going to the job tracker. Bad things happen. The flip side of this is we discovered that our shuffles weren't that bad enough to require going to 2 1 gig bonded. In particular, if we go to a 6 drive configuration, how much disk I/O can you actually generate to fill that 2 gig pipe? You're certainly going to hit peaks, but you're not going to hit enough of them to make it worth the cost. So we have a very cost focus on how much we do, what we use, what we pick. And in the long run, even though we are a fairly interesting percentage of the amount of hardware within the company, leave it at that, the team actually, I don't get yelled at too much about how much I spend because they know that we're doing these sorts of, okay, yeah, peaks, we could go with a 2 1 gig and it would be much faster, but if you have a job that is supposed to do results every day and it takes an extra 5 minutes or 10 minutes, do you care? No, you have a full 24 hours to do this calculation. So it just wasn't worth the cost. 10 gig, we've actually been having a lot of conversations about 10 gig, and mainly not so much in reference to Hadoop, but actually more around Giraffe. So with Giraffe, it's supposed to move a lot of this graph processing off Hadoop and onto its own system. In that case, it's extremely network heavy, and we'll probably look more at 10 gig at that. I've been thinking about it, we're just not there yet. I thought there was another question over here. Yes. So the question is, if we have these 10 grids, do we have any DR? So we actually have one set that's DR'd. We have 2 grids. So I should have put this in the slide deck. So we actually have tiers of systems. So we have an ETL tier, a production tier, and a development tier. Our ETL tier is the most important tier that we have, and therefore it is DR'd. Now, of course, right now there's somebody freaking out because they said, wait, you have a production tier. How come that's not the most important? Well, think about it. I'm doing some analytics. If the data underneath doesn't change, that's really bad, right? So all of our data flows to our ETL grids, our most important tier. They do some sort of massaging, manipulation, whatever, and it is actually dual ingest. From there, they get distributed to their local data centers, to their production grids, and then to their development grids. DR-wise, those are the only 2 that actually run. I'm going to say in sync and just pretend I didn't put air quotes. They're supposed to be in sync. They mostly are. Great question. So the question was, how many CPU cores do we have per task? So per node. I know what you meant. You know what I meant, but they didn't, right? So we actually run dual 6 cores. So we basically have 12 real cores, hyper-threaded. It depends upon the architecture. Sandy Bridge, of course, you're going to get 32. For Westmere, you're going to get 24. So we're literally going almost exactly by core count and not hyper-thread count. And we've discovered that turning off hyper-thread bad in general, but depending upon a hyper-threaded core as a real core for task counts actually hurts you, if that makes sense. So we're pretty much 1-to-1. That's actually not the big differentiator that we use to determine our task count. Memory is actually the first thing we consider. I actually talk about that quite a bit in that top slide deck. I talk actually quite a bit about it. Mm-hmm. You caught me. You weren't supposed to notice that. That's actually an older picture, before we niced the tasks. So that's actually from a 20.2 grid. On a 1.x grid, we actually do run the values niced. And you'll see this nice little pattern where all the user time is niced in yellow, although I changed the color to green on those grids because I don't like that yellow color. And then you can actually see where the data and task tracker, where they're running with normal CPU times, or you'll see these little spikes. And it's actually pretty interesting. And I couldn't, because right now we're starting to bring up our production grid for 1x. I didn't have a really good production workflow to show you like the other slide. Our development grids are all running 1.x. Because they're development grids, it's kind of crazy war land, right? Because people are testing things and you don't really get a good solid workflow. I mean, on average, we're still hitting 50% average on our development grids, but our production grids are almost always pegged. And I just didn't have a really good graph to show you that. Yeah, well, we specifically changed the color. So in that graph, it was actual pure CPU, not niced. Does it make sense? Sure. We don't worry about it. Yeah, amazing, right? So my users love me. Let's just start out with that. What we do is we basically say we have a base data set that goes to all the grids. So essentially we have high availability from that perspective as far as data sets go. But we basically say we don't back up data. So other than that base data set, so if we lose a system, you're on your own. That said, and I actually had this conversation earlier today too. Someone actually asked me, okay, are you deploying DRBD or anything crazy like that? And I said, do you know how many downtimes I've had because of hardware failure in the 4 years I've been at LinkedIn? And he's like, well, I have no idea. One. We had it up in an hour. Do I really want to go through all this crazy stuff to save me an hour over 4 years, not worth it. In the case of Yahoo, since I was there as well, we had many more grids there, obviously, like 20 or so, I think, when I left. And I could, again, count the number of actual hardware failures on one hand. Now you're saying, well, wait, you said hardware, you're cheating. You're right. But the thing is, the software failures we had, HA wouldn't have saved us. They're more external things like network failure. If you have a massive network failure, like your entire core goes down, what does it save you, right? LDAP failures. In particular, we're hitting a very interesting bug with LDAP on Red Hat 6.3 that causes NSLCD to crash. Again, HA, what's it going to save me? Oh, that's right, nothing. So everyone's going to freak out. They're all going to think I'm insane. I don't put much credence into HA with HDFS. I have a suspicion that if you're worried about it that much, you may be using the wrong hammer for the wrong nail. I think there was something, yeah. I'm sorry, what was the? Oh, Mesos. Man, everyone's asking the same questions that have been asked earlier today by other people, which is good, right? I mean, I guess it's all the same thing. So Mesos is interesting. So we actually took a look at Mesos, and we decided the model was wrong. Mesos has a very, hey, I have this node, do you want it? Kind of thing. You know, it's very back alley, here's my overcoat, pick something. When you have something like MPI or Giraffe for graph theory, you actually need all your nodes up at once, right? And so that kind of didn't really work well with what we were thinking about. So as far as what we think about Mesos, we don't think about it. Yeah. So what kind of RAID configuration do we run? Everyone's going to be very disappointed, very, very disappointed. We only run software RAID on the named node and job tracker in associated nodes like Voldemort and things like that. Depending upon what we're doing, it's either 2 RAID 10s, where basically root is RAID 10, and then the rest of the drives in the machine, which obviously only 4 left, are basically a RAID 10 configuration, or we do a RAID 10 for root and then a RAID 5 for the remaining drives. It just depends upon our use case. Bastion hosts, RAID 5. Name node, job tracker, RAID 10. Nothing fancy. Well, yeah. I mean, because drives do fail, right? I mean, that's a simple thing, right? I mean, we can set that up in Cobbler and be done. You know, that's a no-cost HA. How's that sound? You guys are all like, you're lying. I know. Anything else? Hey, I think you've run out of your quota. Go ahead. I have an answer for this, but I can't share it. It was supposed to be open source this week, but it wasn't yet. So I'll give you a teaser. That question is answered by something LinkedIn will be open sourcing within the next couple weeks, if not this week yet. That's a terrible way to answer that question, I know. Can I just say that I have a small altar to Doug that I occasionally burn things at? Does that sound good? Is that a better answer? But yeah, we have tools that we've built to do this. And I wish it was ready, because it was actually in this slide deck originally, and I had to take it out, because it wasn't quite ready. I know. So the question was, do we have you looked at GPUs yet? We've had a couple interns who've looked at it, and they've all ran away, I think all the way back home. I don't know whether they just left the building or if they actually went back to their hometown, one of the two. It just got too complicated, and it basically means we tend to build very generic frameworks for things. Once you have a relevance algorithm for determining jobs you may be interested in, it isn't very far to take that to groups you may be interested in.
And if you do something more GPU, you may end up having to be a little more careful because the data sets are different, sizes are different, right? So that's one of the big reasons why it's just a lot of time investment and we just haven't wanted to spend it. Like I said, we've had interns who, at the beginning of the year, they'll come in, they're all excited, they're fresh-faced, like, we're gonna go do this. And then they start digging into it and they're like, no, we're not. So. Okay, I'm not seeing any more hands. I think we're done. Thank you for coming to hear me babble for an hour.